Right, I think I'm on. Yeah, right. Right, I've got the sheets on my table. Hmm. Right, I had to get the sheet cut in half because I had to cut it in half actually because there's a lot of parts on here and they're all lasered into the sheet. I push them out. So let me just see if I can see what I'm looking at, because then right, basically when I'm ready to take a part out, all I have to do is push it out from the back, but I put some tape on there for now because I kept catching them with on my clothing and stuff, because they're sticking up, you see. And these are the laminations for one side. Now if I just poke one end I can lift it out and show you what I mean. If I can get the damn thing out, because it's stuck to the sticky tape. That's what I wanted it to stick to the sticky tape, because they kept coming out. I kept catching them. Right. But when I'm ready to take them out, I'll just cut the back with a knife, basically. I'll just push it with my nail. I'll get it. There we go. I'm pushing it with my nail at the back. So, and I'm bending it as well. So, when I'm actually ready to take these out, I just take the tape off the back, really, when I'm ready, because I put some tape on there. But I don't want to bend them, obviously. That's the reason why I put the tape on, because they're kind of fragile, because there's actually a 1mm bridge that links the two halves at the top. I'll just give you a rough idea of the size of them. There's a ruler. You've seen the measurements, and that's 80mm up here. From the bottom of that lamination to there, it's 80mm and 3mm thick. 3mm wide, sorry. Yeah, so that's one panel. So now you just basically push them out when I'm ready. As I say, I put tape on there. Now there's the other panel which I've already taken some out of. Hang on, just swap this around. There's the one where I've taken a couple of panels out, couple of laminations out already, which are the ones I'm using for testing. Oh, and actually that one's poking out, so I can lift that one up to show you. You just literally lift them out like that, and then you snap them off when you want to use them, because they're just joined by a tiny little bit of steel at the bottom. And you just bend them backwards and forwards and it snaps them off, and then they're ready to use. And obviously they're kind of fragile because there's a bridge in the middle. It's about 1mm, so I kind of like to keep them in there until I'm ready to use them as well, because they can start to go rusty as well if you don't. I WD-40'd and cleaned them all while they're in the panel, because it's a lot easier to clean them all when they're all together. So you can see why I put that tape on the back, because they stick up sometimes, and you catch things on them. Anyway, to get all that cut, it was about 33 quid. £33 in UK money, so that's not bad, is it? That's that's like equivalent to what? About 6 packs of cigarettes in our money. Probably less than that, actually. So it's not like it cost a fortune. It didn't really, but I mean, it's a bit of money you can save up after a couple of weeks, and I just noticed there's a bit of stuff on there. I don't know what that is because I cleaned these. I don't know what it is. It's not. I don't think it's rust. I think it's just a bit of. There's a bit of brown stuff. Don't know what that is. Probably a bit of glue or something. Oh, I don't know. Anyway, it's so easy to clean them when they're like this. So I decided to leave them in until I'm ready to assemble it all. I'll just have a look at the chat because so I can't see the chat right now. Yeah, it's yeah, you just push them from the back. Yeah, but I'm the one that put the tape on because normally they come wrapped in bubble wrap or something, but I didn't have any bubble wrap, so I just put all this brown tape on. Look, just peel it off, and when I'm ready to take them out, I can just peel it all back and then pop them out. So you see this one here, I can pop that one out now. Look, pop that one out. That's how easy it is to do. But I'm going to leave them in for now. Because when they stick out, you catch them on your clothing and then you can bend them, and I don't want to do that. That happened actually. That's the reason why I put the tape on, because I went and caught one of them accidentally. I had him stood on the chair next to the chair, you see, and I cut the panel in half. I slid one panel over the other panel, and I caught one of them and bent the damn thing. But I straightened it anyway. I managed to straighten it all right. So this one really wants to go underneath that one because for some reason the other one is the one that's giving me the problems. And there's actually, it's about, I think when I got these it was about 800 grams or something, almost a kilogram or something. And these are the end laminations. These are the ones that goes on the ends. These are a little more fiddly getting them out. These little ones are a little bit fiddly, because I'll show you anyway. Hang on. Right, the two that I took out are actually in here right now. And now there's the little square ones, look, that go in there. Like, there's different sizes to these as well. Some of these are 3mm wide, these are 3.5mm, and you can, I don't know if you can see this, but I'll put this on a white background, but these little ends, that end is 3.5mm, this end is 3mm, so we're talking about 0.5 mm difference. And the reason for that is because the inside diameter is a little bit less than the outside one, you know. So that's 3mm from there to there, and this one's 3.5 from there to there. Right, so and the thick end goes on the outside and the thin end goes on the inside. So I'll put that back in just to show you what I mean. And the magnets actually hold it in place as well. I can actually lift the whole lot up because that's magnetically locked to this now. So I'll take that off again. Now it lifts away. And take my laminations out of here. I'll just take this bobbin off a minute. So I've got this other one on the other end. Right, if I take this out of here, you can see how it goes together with the magnets in the middle. So there's two on each side. If I take that off there, it's only held in place by these magnets, and there's actually 4 magnets, and south on one side, north on the other side, and south on this side, north on that side. So it's rotating, and that's basically how this switch works. When we close the circuit on one side, it latches on the other side as well. Now the way to adjust that, I'm going to be making the one of these laminations on one end is I'm going to adjust the air gap to affect the amount of switching latching that we get. And also this one's 3mm, this one's 3.5mm wide. So that's the inside, and that's a slightly different design if you look. It's got little lips on there. I don't know if you can see those. It's in the drawing anyway. Got like little hooks on it, so I can see which is which, and this has only got about a 1mm bridge on there. And this other one has got 2mm bridge, and there's no hooks on there on this end. So you can easily spot which is which, you know. Makes it a lot easier to spot it. And that's why I was having a lot of trouble with my spacing, which is why I've had to do some filing, because it's really precise to get these just right. And it just drops in here like that. If I can get it in. Can be a bit awkward sometimes. I haven't got that in right properly. I could wiggle it a bit. So this one's still a bit, it's a little bit tight in the middle, I think. Anyway, then I'll put the bobbin on the bottom. And I've got to hold the middle together so it goes in the slot properly. Alright, then it goes on there. Then I get my end laminations. I've got this upside down now. I think that's the right way up. Now we have some attraction on here at the moment because I've got this one on there and it's actuating it. Actually, it's turning it on. Now it's not on as much as it was now. It's still on a bit because it needs a coil to actuate it. Really, it needs to be the coil to switch it. Just get these right. Just trying to get these right way around because it's confusing. Right, that's the thin end. There's actually an interlace that goes on once I put this together. There's 3 bobbins, so one of these is longer than the other, so that one of them overhangs, and then the other one interlaces with that middle bobbin. So if you look at my diagram, you can see that. Some of these bobbins still need a little bit of fine filing, but they're just about there. I think Actually, they're not bad. They're pretty close now. I'll put this one on. Just a little bit tight in some places. I would never have made these things by hand, honestly. I mean, it would have been a lot of work. They're locked together now. Now, the magnetic field is weak because it's in a closed circuit, and that's what you want to energize the coil on the other end. Oh. Yeah, because what I want to do, is one end. I'm going to have some rubber foam that goes around the base to reduce any noise and vibration it might get with higher frequencies, making these laminations vibrate. And I'm going to be able to adjust the air gap by having these ends adjusted out, in and out. So I'll probably gonna have I'm getting my own voice, it's driving me batty. So basically I'm gonna have a false cap on this end that holds these little laminations. Then I'm gonna have an adjustment screw of some kind, which I'll probably put a bung in there and then have a screw or something, so as I tighten it, it pulls the cap further back or something like that, to adjust how far this air gap is. Or I could just put a wedge of material in between the laminations, like a piece of felt or something, to adjust the gap. It just depends which works best. I'll probably have to use a piece of material or something. I don't know yet. It depends how rigid I can attach these to a thing on the end so they don't tilt. They have to be, I'll probably glue them onto something which I can pull back and adjust them all equally, so I can adjust the air gap, because they do want to pull towards the magnetic field, and then I'll be able to adjust the amount of gain I've got on one to balance the field, so that the actuation is in a sort of equilibrium, you know, like I was telling you about seesaws and everything. Well, you've got to get the field balanced so that it's not actually feeling that reverse what do you call it, that equal opposite reaction thing, yeah, that lens effect. So we've got to balance it so that when it's this closed circuit, because you see what's happening is one coil is subtracting north, right, and when it subtracts the north field into this loop, south is no longer being cancelled on the other side, because south is being cancelled by that north that we're subtracting. So when we subtract the north, right, say on this end, that south is going to make a circuit on the other side, right? So we're actually subtracting north. So when south, the opposite reaction, tries to push back, all it's going to do is encounter, it's not going to really encounter much, because north is already in another loop, you see, it's isolated in another loop. But if south could overcome that switched effect that where I'm pulling north away, then if anything it would just simply pull that north back, right? But from all the tests I've been doing, it's the static tests I was doing with that hang on, where is it? Right, using this static test, which is these magnets, which is the same principle but on a larger scale, right? Now this is north on this end, right, and this is south on this end, right? Now I've got a gauge that measures the south pole magnetism, right? Now if I get my magnets to bias this, I'm using big magnets. This is south lot, right? So when I put south against north, I'm subtracting north. And what? Oh, I'm on this piece of steel plate, so it's not going to work too well. There's a big steel plate underneath, so it's right. You can see it's pushing south lot, right? You can see south is being deflected. Okay, right. Now when I move these magnets, I'm no longer subtracting north, right? So if I put the other magnets there, which are also north, you'll see that south is actually being attracted to the it's no longer being pushed, right? Because north is actually stronger. So right, when I use south, it's being pushed. That gauge isn't very strong anyway. It's very weak, that one. It doesn't pick up much, but it doesn't actually push. If I get the other gauge, which is north, right? That's the north gauge, right? I've got it written on it, north. When I put north over here, right? If I try to push north, look, you see how it pushes north, look. If I put north over here, and I try to push it, oh, I can't. Look, it's being blocked by this north here, right? It won't push that north. Oh, my computer's gone to sleep. Look, I've got north on here, look. That's north as well. South's over there. Right? It won't move that. The reason is that ends off. It's completely off. And to show it I mean, there's my nail clippers. Right? It's not sticking to this end, it's actually jumping underneath. It's not sticking to, this is a spring clip, right? Now look, it's not sticking, look. Now if I turn this around so that I'm pushing south out there, now we've got attraction to the south, look. We've turned south on, right? South is on very, very strong, look. But we can't push north out of there, because if I turn this magnet around, so that's north, and we're against north here, nothing. North cannot get through because south is blocking it, right? So it's a one-way switch. However, if I reverse it, the whole thing, now north will come out this end. Right? To prove it, that is really strong. I mean, look at that. I mean, I'm nearly lifted the damn thing up. Now, I can turn it off by reversing these biasing magnets. Right? See how strong that is? I'll reverse these magnets so south is on this side now. So I've got south and south, and nothing. Well, hardly. There's a little bit there, but it's not strong at all. Actually, it's gone now. So what have we got coming out of here? Nothing right now. And what am I pushing out this end? I'm pushing south. South can't get past this south on this end. Only north can come out this end. So I'm pushing south right now. This is the south gauge. That's how my switch works in this device. So that's why we have to actuate from each end, because it's a one-way switch. We can only actuate north at one side and south on the other. We can't actuate north-south on one end, because we will overcome our whole switch potential. That's the reason why I've had to separate it. So that is on actually right now, because I'm not biasing it. There's a bit of north there, but when I put south on here, it's off now. Look. It's weak, it's very weak. I can't get south coming out this end, but I can turn north off. That's the whole point. So turn this around so we've got north. Now it's going to be really, really strong. I'll get the north gauge, which is this one. You can see, oh, hang on. You can see it's pushing the north gauge. I'll move this biasing magnet away, put the other end on, and it's just turned it off. Turned it off more. Turn south on. No, sorry, north on. North off. But to get south, I have to use the other end of the switch and turn it all around. Now we're using the north gauge still. Got nothing. Turn it around. Got nothing because this is north gauge. We've got south coming out this end now. When it's turned on, there we go, it's on now. Turned off, turned on. As I say, this gauge is not as sensitive to the other one, it sticks a bit. And the other one's a little bit longer, so it's more sensitive. But these switches in here are supposed to do exactly the same thing, which I've been trying to work and design it. And the reason for them little cutouts is to try to limit the amount of lens that gets back through into the actuation coil. That's the reason for them little notches. Because I want to subtract the north field, but I don't want to be pushing the south field through as well. Yeah, thanks Hyde. Yeah, okay, you get some sleep because I'm going to go soon as well. I'll try and save this video on this channel because it wouldn't get saved on the other one. Oh, I'm stiff. Anyway, thanks for watching. I'll just save it. Good night, Hyde.